We'll go with the right. Guys, right. Redundant. Array of independent or inexpensive disk. Why we need to struggle? We have a Google. RIDE full form. Redundant array of independent disk. It is also concept of virtualization concept only, but redundant array of independent disk or inexpensive disk. Inexpensive disk. Two statements are there. Guys, RIDE is a concept. You can implement RIDE concept using a software and hardware. Usually in organizations they use a hardware only. Hardware means there is a RIDE controller. Using the RIDE controller, they can create a RIDE. Sometimes RIDE controllers are RIDE controllers are a built-in as the adapters or motherboards on your server motherboards. RIDE controllers are individual controllers are a built-in SCSI or a built-in motherboards. Okay, built inside a motherboards. On motherboard it is there. Okay, so like that. So next one is software RIDE. Hardware RIDE by using a RIDE controller. A RIDE controller maybe it's a built-in feature of your SCSI or maybe on server motherboard having a RIDE controller. So on server motherboard. Okay, so it's a very simple hardware devices. Next, what is this software RIDE? Using some softwares. For example, we can use Microsoft servers. You'll get a RIDE concept. If you use a Microsoft server, you can configure RIDE. With a software means using an application. Okay, or Linux, you can use Linux or some other applications. Using some application, disk management applications, you can able to do it. So that is a software RIDE. So whatever it is, whether it is hardware RIDE or a software RIDE, the RIDE levels are RIDE levels only. RIDE types are RIDE types only. RIDE facilities are RIDE facilities only. It depends upon you to choose it. I'll tell one thing first. Span volume. What is this span volume? Span volume is not RIDE level. Remember that one. Okay, so span volume is not a RIDE volume. So here it is. I'm going to explain what is this. You have an individual disk. The disk you can able to create a partition, right? That's it. So think like this. You have a disk. You can divide the disk into small parts. That is called a partitioning. That is called a partitioning. Nowadays we call that as a new simple volume. Means single hard disk. You are logically dividing it. Logically or virtually, you are dividing a single hard disk into small parts. That is like a partition. But in this concept, you have a disk. The disk does not enough for your space. Enough space is not there. For example, my disk management. Now you can go to this one also. See it's only 33 GB is available. Here it is only 15.6 GB is available. Here it is 39.4 GB is available. Now I got a challenge like a disk is not enough space. What I have to do it? I have to increase my space. I have to increase my space, but no space is available here to increase. So we can combine the disk space to other empty space, unallocated space, and become a large size. For example, initially my drive is D drive and I have a 1 terabyte of drive. I want to combine with other, for example, 2 terabyte of drive. Now I become my D drive is become 3 terabyte. The total size of the D drive become 3 terabyte. Okay, this is a spanned volume. Combining a 2 disk and become a single large volume. Single large volume. Create a single large volume. No need to take same volume sizes on each disk. Okay, that is single. That's why I put a 1 terabyte, 2 terabyte. Okay, no redundancy. Okay, no failure kind of stuff. Okay, no single disk failure. Disk failure. If the disk is failure, total data loss. Total data loss. It is not a write level. Now it comes to the write level one by one. So write level 0, that's the first one. It is a stripped volume. We'll see how write 0 is there. Look at here. Okay, so this is my D drive again. I combine 2 disks. Okay, this is my D drive. I combining 1 terabyte and 1 terabyte. Compulsory, both the disks must maintain same space. Okay, same space. Okay, this is called a first of all, by combining, I'm getting total volume sizes. My D drive sizes become 2 terabyte. Okay, so here it is. We combine 2 or more disks. No disk failure. Disk should not be failure. If disk is failure, can't able to access the data. If any disk failed, can't access data. Can't access the data. This type of write is called write 0. The name is stripped volume. And also no parity. This is about a write 0. So when we use this write 0, write 0 only we use write 0 if in case, just in case of you don't get a more space, like you are about to finish your disk, like you have a very huge amount of data, users are accessing your data. Now your volume size is not enough. Then what to do? Add one more disk and create as a stripped volume. Compulsory you have to take same sizes only. Okay. Guys, understand stripped volume?
Yes, sir.
Next. Again, same thing. I took a 2 disk. Here, this also D drive. I took a 1 terabyte of each disk, compulsory, same size you have to take it, 1 terabyte, 1 terabyte, 2 terabyte, 2 terabyte. Okay. But here, if you see this, the first one is a stripped volume. You can get a more big size disk. Okay, you can get a very big size of the disk size. Volume size is very big one. You got a 2 terabytes. But here it is column disk failure. If any disk is failure, column. For example, I have a computer or a laptop. It contains operating system, applications, users data, like that. All of the sudden disk failure. Your work will be stopped, right? You can offer a new hard disk, but still old hard disk data, application settings, anything, you won't get it. So what I'm trying to do is, if my disk is failure, no problem, user can access the data. So in this one, we use only 2 disk only. Use 2 disk only. It is a single disk failure. Without parity. Without parity. Meaning is, if any disk fail, any one disk, if any disk is failed, can access data. Can access data. There is no parity here, but I will explain in a write 5 what is the meaning of parity. Okay. The size of the disk, total size of the disk, you will get a 1 terabyte only, because same data, like what are the data in the first disk, same data stores in second disk. So obviously total disk size is 1 terabyte, means one single disk volume only you are getting. This is called a RAID 1. This is a RAID 1, also called as mirror volume. Mirror volume. Now, what is the problem in this mirror? Mirror is for only home office users, home purpose, not for others. Okay, so it is only for I have a system, so I need a redundancy, not a big storage, but redundancy is very important. I go with the mirror volume. Okay, that's it. If you replace the disk, of course, loss of 50% of total value. Loss of 50% of total value. If in case in a mirror a disk is failure, one disk is failure in a mirror, so obviously you replace the disk, the mirror will broke. Mirror will broke. So don't worry about it. So that is a mirror volume. Now next one will go to RAID 5. Here, for example, I take a 1 terabyte, 1 terabyte, 1 terabyte. 3 disk I have taken. Okay. So this is a RAID 5 volume. The RAID 5 type do not have any name. So it's a RAID 5 level. So RAID 5 volume only. So we don't get any special names are not there here. It is we use at least 3 disks. 3 or more disks. Actually, it is the as per the statement, it is 3 or more disks. You have to use it. Okay. Next, it is also a single disk failure. Parity. Parity. So I will explain the parity. So don't worry. Again, if any one disk failed, still access. Okay. So it is a RAID 5 volume. So when you come 3 disks with parity, single disk failure with parity means it is RAID 5 volume. What is this parity kind of stuff? I will have to tell total size also, right? So 1 terabyte, 1 terabyte, 1 terabyte. Combinedly, you will get only 2 terabyte. So here it is very simple. 2/3 volume you will get it. Here it is 1/2 volume means 2 disk you use it, only 1 disk, like a 2 plus 2, 2 terabyte in a RAID 1. 2 plus 2 plus 2, 4 terabytes you will get it. Okay, so 2/3 of total volume size you are getting here. Okay, next. What is this parity, guys? Look at here. Parity is also nothing but a data. You have a data. From your data only parity bits will be created. From your data only parity bits are created. For example, you store a data stored in a one disk. In other disk, their parity bits will be stores. Their parity bits will be stores. Okay. So in one single disk, you put a data, any data. So you copy a data into D drive. Data went to a disk, and the other disk will get a data's parity bits. Okay, data's parity bit stores in a other disk. What is the advantage of that one? What is the advantage of that one? If in case a single disk is failure, a disk is failure. Okay, for example, this disk is failure. You remove the disk and reinsert the disk. You remove the disk and reinsert the disk. Now, automatically, the data will be regenerated as a old disk. What are the disk content? Old disk content. That data will be regenerated automatically into the new disk. It will be regenerated automatically into the new disk. How it is possible? Because of parity. Because of parity. Guys, understand or are confused? RAID 5.
Understand, sir.
Okay. Last one I'm trying to say here is RAID 6. Okay. Actually, there is a not a particular RAID 6 is there. RAID 5 extension is RAID 6. I started with the RAID 0, RAID 1, and I went to RAID 5. Where is RAID 2? Where is RAID 3? Where is RAID 4? Those rights are there. Those rights are available, but it is not implemented for a production purpose. Okay. Here also I take a disk, but this time I take a 5 hard disk. Each one is 1 terabyte, just an example purpose. Okay. This is called a RAID 6. I used here 5 disks. Okay. It is a 2 disk failure with parity. It is also similar to RAID 5, but 2 disk failure, 2 disk failure, 5 disk we are using. If any 1 or 2 disk failure, can still access data. Okay, so the total volume you will get it means it's a 2 disk failure, means out of 5 2 disk failure, it means it will give 3 terabytes of volume. Okay, so same thing concept like a RAID 5. The parity bits will be created into the other disk. It means in one disk you put a data, means automatically data you copied into D drive, data goes somewhere in the drive. So whenever it is got the data, the parity bits will be created into other hard disk. So what is the advantage? So if your disk is failed, you remove the disk and replace with a new hard disk, and the data, suppose what are the data should be in that remote disk. Is there what is the data in the remote disk? The data will be regenerated. That is called a RAID 5 and RAID 6 parity bits. Not only this, guys, there is a RAID 10, RAID 50 is also there. It is nothing but combination of RAID 1 and RAID 0. Okay, or a combination of RAID 5 and RAID 0. Is like that. RAID 10 means it's not a 10. So mirror plus stripped. 5 means RAID 5 plus stripped. So this is the basic things of your RAID. Okay. So in the notes, what it is there? We use to R more disk. Again, it is also combine disk become single large volume. Span volume also same thing, but span volume is not belongs to any enterprise kind of stuff. Okay, it is anywhere you can implement a span volume. Okay, and of course no disk failure. Different type of devices you can also connect it. But RAID 0 is triple volume is faster than that one. same volume size. Disk, we have to take it. Okay. It is also no disk failure and no parity concept. Okay. So to create a big volume sizes, you can go with the write 0. But if disk is failure, people cannot able to access any one of disk failure. Not access that. Next level is write 1. What is the write 1 name? Anyone?
Mirror.
Yeah.
Mirror volume.
How many days? Only 2 disk only. Combine 2 disk and become okay, not required. So this is also same thing, same volume sizes we have to take it. It's a single disk failure. Without parity. Next, if any disk is failure, okay, you can access data. Okay. That is about a mirror. But here also volume size we have to discuss. Okay, here also volume wise. For example, I have taken 1 terabyte plus 1 terabyte of storage. You'll get a 2 terabyte of size. You will get it. In this example, one terabyte plus 1 terabyte. You get a 1 terabyte only. Because of half of a disk, we don't use it. Next is RAID 5. RAID 5 volume name is RAID 5 only. How many disks? 3 or more disk only. This is a single disk failure with parity. What is the parity? Parity bits will be created in other disks. Means like I have a data in the disk in a disk. So other disk having a that data's parity bits. Okay. So then if any disk is failure, still your data is available. Any one disk failed, still you can able to access data. But what is the difference between RAID 1 and RAID 5? RAID 5 having a parity, RAID 1 don't have parity. It means if disk is failure, I remove the disk and replace the disk, data automatically created into the new disk. Okay. Size examples: 1 TB plus 1 TB plus 1 TB, you get a 2B. Okay, this is RAID 5. And what about a RAID 6? RAID 6 is same as a RAID 5 only. Only thing is number of days are changing. I use 5 days here. It's a 2 disk failure. Means it's allowed to add thing. with the parity. If any one or two disk fail, still you can able to access the data. You get a 3 disk volume. In gain 2/3 of total volume size only will get it. So here it is 1/2 of total volume. Here also same thing, 3/5 of total volume size. Okay, so write 50. Okay, 10. These are all combination of write 5 and write 0, and write 1 and write 0. Okay, guys, this is about a write yesterday. Okay, so someone got a doubt, I think so. What is why I said write complete with the practicals? Because how to do practically it is showing. Okay, better to go once. Better to go to how to do practically. You can try also, no problem. So this is about your write, guys. That's it.
Sir,
Yeah, tell me.
in write one, how can I access data? There is no parity.
Uh, it is very simple concept. Very good. I put a data. I just I don't put any drive, right? So I put it in a drive, means I put a drive data in a D drive, E drive, F drive. It shows like this only. Okay. When you put a data, so I put some data here. Data stores in the hard disk. Data stores in the hard disk. Right? That is we know it. But internally for mirror, what happens? So whenever one physical disk got the data, it copies into other disk. It copies into
Other disks.
other hard disk automatically. It's same in the write file also. Same in the write file also. But in a write file, it copy the data into other disk in the form of parity.
Parity. Okay.
Okay. In a write one, we don't use any parity. It is direct copy only. That's why if one of the disk is failure, you can able to access the data.
Okay, sir.
And that's a 1.5 total size. It's 2 terabyte totally. 1 plus 1, 2 terabyte, but we got 1 terabyte only.
Okay.
Okay.
Okay, sir.
Because parity is a smaller size bits, right? Not as like a big size. Like I have a 100K file is there. Parity file is maybe 10K. Understand?
Okay, sir.
So parity is very less. So for you have your own computer, your own laptop, you can do mirroring. Okay. For example, just for example, usage. A small organization, very small shop is there. You know, a shop, your friend shop or your own shop is there. Hard disk can be failure anytime. So what you have to do? Insert another hard disk, make it as a mirror. If sudden crisis occur, like a one hard disk is failure, no problem. Still you have a data in the thing. Okay, still we can able to access the data. Next, write file is a little different from mirror. Write file is for enterprise solutions because of normally we cannot offer write file. But write file works in the servers. It won't work in the regular operating system. We need a server operating system. Okay, and we have to take 3 minimum disk, and you will get a 2/3 volumes. But in enterprises, RAID 5 is a more advantageous because of if one disk is failure, you remove the disk and reinsert the disk automatically. Your RAID understand there's a new disk and regenerate the data into new disk. So that's the point here. That's it, guys. Take a break. Have a tea and coffee.